Hi folks, today we're going to work on an impulse momentum theorem example problem, and the one that we have here is from the G and Coley textbook. It says a 0.145 kilogram baseball pitched at 39 meters per second is hit on a horizontal line drive back toward the pitcher at 52.0 meters per second. Calculate A, the change in momentum of the baseball, and B, the average force on the ball, assuming the contact time was 0.005 seconds. All right, so the first thing that we want to do is write down everything that we know. All right, and we have that here, so let's get the pen going. And we have the mass of the ball. So the mass of the ball is 0.145 kilograms. And as always, writing with this wireless slate is difficult for me. Okay, and it's hit at 39, or it's pitched at 39 meters per second. So that's its initial velocity. So we're going to go with 39.0 meters per second. And the final velocity, it says it's hit back toward the pitcher at 52 meters per second. We're going to talk about that in a second, but I'm going to write down the 52 here. And this says that the contact time is 0.005 seconds. Okay, now one issue with this, we noticed that the pitch was moving towards home plate and then it's hit back in the opposite direction. These can't both be positive because they're moving in opposite directions. One of these is going to have to be negative. So we can call the final velocity negative, or we can call the initial velocity negative. What I'm going to do here is I'm going to make the initial velocity negative. So in other words, away from home plate out towards the outfield would be the positive direction, and towards home plate would be negative. You could do it the other way around. It will change the sign in the end, but it doesn't change the magnitude. Okay, so we have negative 39 meters per second. All right, so the first thing we're going to do is find the change in momentum, so delta P. And if you remember, change in momentum is going to be the final momentum minus the initial momentum. Now, since the mass of the ball doesn't change, what we can do is multiply the mass by the change in velocity, because it's going to be mass times v final here, and it's going to be mass times v initial here. So we can do the mass, which is 0.145 kilograms, and we're going to multiply that by the change in velocity. So we have the final velocity, which is 52, minus the original velocity, which is negative 39. And we can calculate it out from there. Okay, so if we do that, we have 145 kilograms times 52, that's 39. Okay, and I get 13.195. 13.195. So the change in momentum, 0.195, and our units are kilogram meters per second. Okay, now the second part says what's the average force on the ball, assuming the contact time was 0.005 seconds. Well, if we remember, the impulse momentum theorem says that the change in momentum of something equals the impulse, and impulse is force times time, average force times time specifically. Okay, so what we can do here is divide both sides by the time, and that will give us our force. Now here's the nice thing. We already know what this value is right here, delta P. It's 13.195. We already did that part. So if we take that 13.195 and put it here and divide by the time, then we can get the average force. So here we go. We're going to do 13.195 divided by 0.005 seconds, and I get 2,639 newtons. So our force is 2,639 newtons on the ball, which is a big force, but we got to remember that that force is responsible for changing the ball's direction from, moving towards home plate to moving away from home plate, and also for sending it in that direction at such a high rate of speed. We're talking 52 meters per second. That's coming off the bat at over 100 miles an hour. So it's moving really fast, and a large force is going to be required in order for that to happen.